Continuing metric spaces. Distance between point and a subset of metric space. Let XD be a metric space, A be any subset of X, and small x be any point of metric space X. X small x is any point from which we need to find the distance with the subset. X is a metric space, A is subset, X is any point. This can lie inside A also, but in that case distance will be 0. So we need to find the distance of X from subset A. So there are many points in A, they will be on boundary also. We will find the distance with each and every point of A from X, and the distance which will be the least out of these, that will be the distance from X to A. So the distance of X from A is defined as dx comma A is infimum of collection of all the distances dx A, where small a is a point of set A. So we will be capturing distances from X to each and every point of set A, and whichever will be the minimum, that is the infimum or GLB of this collection, of all these distances, will be the distance from X to A. Now for example, if D is a metric on usual metric R such that dxy is equals to modulus of x minus y for each and every x and y of R, and A be any subset inside the metric space R. Suppose A is close interval 2 to 4. Then distances, we need to find distances from different points to A. So distances of points X is equals to 1, suppose we need to find from 1 to A, then from 3 by 2 to A, and then from 3 to A. These are the different questions we are considering. When X is equals to 1, then D1A is given by, suppose this is real line, 1 lies here, interval 2 to 4 is this, 3 lies in the interval. So the minimum distance will be captured by from 1 to 2, that is modulus of 1 minus 2, that is 1. Similarly, distance from 3 by 2 to A is given by 3 by 2 minus 2 modulus. The minimum possibility is given by 3 by 2 to 2. That is 1.5 minus 2 modulus 0.5, that is half. And if we want to know the distance from 3 to A, since 3 lies inside the set A, so distance will be 0. Whenever you are finding distance from a point with a subset and the point lies in that subset, then distance is 0. Next is diameter of a subset. Diameter is the largest distance. Suppose this is a metric space A be any subset of X, then through all the pairs of points lying in A we'll be finding the distances, and the supremum of this collection will be the diameter of A. Let XD be a metric space, A be any non-empty set, then diameter of A, which is denoted by del A, del means diameter, is given by supremum of all the collection dxy, where x and y are 2 points of set A, both belongings to A. That is supremum, or you can say the LUB of this collection, where we have found all the distances between any 2 points of set A. Supremum of this collection is diameter. Also, diameter can be finite or infinite, depends upon the set. If diameter is finite, then we say set A is bounded. Set A is bounded. And diameter is finite means d of A is less than infinity. Now for example, we are taking the same usual metric on R because it's the simplest metric where we can find and understand the concept easily. If A is 1 to 5, B is this, C is this interval, then diameter of A is 4, 5 minus 1, diameter of B is 2, diameter of C is 2. Here it is meaningless whether the interval is closed or open because the distance is the maximum, whether the point is included or not. In case of real, diameter is infinity. We don't use it anywhere but for just the sake of knowledge. Distance between two subsets. Let A and B are two non-empty subsets in metric space XD. Then the distance between A and B is given by, again if you are finding the distance it will be infimum. In case of diameter it's supremum. So distance between A and B is infimum of all the distances which have been taken from points in the two different sets. Suppose A and B is this, so distance will be calculated with any 2 points in between the sets, but the minimum distance, which is this, the smaller line in the diagram, is the distance between A and B. If D is usual metric for R such that dxy is this, then we choose any two sets A and B to let you know the distance. How we find distance? A is 1 to 2, B is 2 to 3, and distance of A to B is 0. Right? These are just touching sets, because in one set 2 is not included, in another set 2 is included. See, this is the case when they are overlapping, their intersection is non-empty. In case they have something in common, obviously the distance is 0, but converse is not true. Like in the above example we have discussed, they have nothing in common, still distance is 0. A and B are non-empty subsets of X, they have something in common, A intersection B is non-empty, then the distance will be 0 for sure, but converse may not be true. By above example you can check the distance is 0 but they have nothing in common. Right? So this is one example. Another example is, suppose I am taking A set 1 to 4, B set 5 to 6, then distance is 1. The smallest possible distance is 5 minus 4. In